Hello, thank you everyone for coming to the Regenerate conference. Today I'm doing a talk called Rethinking Autoimmunity or Rethinking Autoimmune Disease. So I've been thinking more and more about this, and the whole model of autoimmunity just doesn't really make sense to me. I don't think that it's describing what we are seeing in real life accurately. It's a theory that's been developed over many years and has been changing and evolving during that time. But I think it's time for a new, fresh look at it as well, or maybe not so fresh as you might see. So the current explanation is for autoimmunity. It is generally thought to be your body attacking itself. So your body has to be sensitized to itself, typically by molecular mimicry, meaning that something comes in, either a pathogen or some sort of toxin or some sort of environmental exposure. And your body attacks this and then makes antibodies towards it that are similar enough to antigens in your own body, antigen being just molecules that your body makes, that there's a cross reaction. And so then you get this cross reaction with your own body, and then it starts getting hypersensitized to your own body and getting more and more specific for the antigen in your own body. And so you mount this autoimmune response and you start attacking yourself. And so you get sensitized to specific organs. You attack your thyroid, and that could be Hashimoto's. You attack your gut. You could get Crohn's disease or ulcerative colitis. With your joints, it could be rheumatoid arthritis and so on. So it's thought to be that this is different environmental factors, genetic predisposition, and some sort of trigger, like some sort of pathogen that comes in or some sort of exposure. And then this creates either an autoimmune response, either through reactive T cells, possibly antibodies, or even immune deposition in different tissues. There's three different kinds of autoimmunity that we know of. The genetic predisposition seems to be plausible, seeing as that autoimmunity tends to run in families, but then again, diabetes runs in families just due to the nature of what families, families tend to eat the same thing. When you're being raised by parents that are eating a certain way, you're raised to eat that certain way as well. However, people with Down syndrome, which is trisomy 21, they are actually very predisposed to getting autoimmune disorders. And generally in their 30s, they'll have quite a number of autoimmune disease and quite a heavy burden of autoimmune diseases. So there does seem to be some sort of genetic factor that is at play there. So, as I said, you have some sort of sensitizing event, and you are now sensitized to your body, and you think that your own body is some sort of infection or a pathogen that has to be clear, and then it just attacks and attacks and attacks and basically tries to destroy this threat to your body. However, I don't think that really will hold up to even light scrutiny. I think there's quite a lot of flaws with that. Some flaws with this. First of all, this doesn't act like your body's attacking a pathogen. When your body attacks a pathogen, it does a full court press until that threat is dead. If you have a pneumonia, your body has to contain this and attack it and keep attacking it until either it's dead or you're dead, because those are the stakes. If you cannot contain a pneumonia, you will get septic. And if you cannot contain that septicemia, you will die. So the stakes are very high here. However, in autoimmunity, we see this flare and relapse sort of pattern where things will get worse and then they'll get better and then they'll get worse again. And so we have this up and down response. If you did that with an actual pathogen, you'd be dead. A simple cold would kill you. And we see this with people that are immunosuppressed by, for various reasons. Even very mild infections that normally wouldn't kill anybody can kill them, or maybe not even infect anybody, things that normally we wouldn't see, different fungal infections or parasitic infections that normally your body would have no problem taking care of. Now all of a sudden they're running rampant around your body, getting into your brain, etc. So these are things that we see when the immune system just takes a nap. And so that's not going to happen. Your body is not going to just take a nap and say like, well, yeah, we had a good day, but we're just going to take this weekend off. It doesn't happen like that. It's a full court press, and you ramp up the attack higher and higher and higher until the job is done or you're dead, because again, those are the stakes. And also, we wouldn't see what we're seeing in practice, which is when people remove plants, change the way they eat, these autoimmune conditions do subside. And so if your body was truly sensitized to your body and just thought that your thyroid was an abscess, it wouldn't matter what you ate, because it would just be sensitized to your thyroid, and that thing has to go. And that's not how it behaves. Also, you really can't have your immune system attack you. It's designed explicitly to not attack you. So when I was taking postgraduate immunology, it was very clear that autoimmune diseases could not actually exist in the way that they're put forward. So when your immune cells are being matured in your thymus, they are exposed to every single antigen that your body can make. And remember, the antigen is just different molecules that your body can possibly make. And so every single antigen is exposed to your immune cells. And if they react even weakly to any of these antigens, they're killed. So the only immune cells that your body can produce and have in your systemic circulation that can have a T cell response or make antibodies towards any sort of pathogen have already been programmed to not be able to attack your own body. If they were able to attack your own body, they would not exist. So something would have to go wrong with that maturation process. And that's sort of the idea, is that, well, something goes wrong with this process, and then your body becomes sensitized to itself. But that doesn't make sense either, because again, if you are sensitized yourself, you should act like this was an infection, and we don't see that. Also, molecular mimicry wouldn't make any sense regardless, because if your body can make an antibody to a virus, a bacteria, something that then cross-reacts with your own body, well, then it was capable of making an antibody or an attachment that could attack your own body in the first place. It wouldn't need that intermediary. It has the ability to do that. When your body is making antibodies, it's just making different combinations of the active portions of the antibodies, and just changing these and sending them out, and seeing what sticks. So it's this constant expression of random composition of this active reactive area of the antibodies, and seeing what happens. And when they stick to something and they attack something, then it's sensitized. They bring that back and they say, okay, well, this latched onto something, so obviously it needs to go. And so now then that gets sensitized, and you spread this out to a bunch of cells, and they start making more and more and more of this antibody, and they just start pumping these things out. You wouldn't need molecular mimicry to do that. You would need something else being closely related to then cross-react. You could react in the first place. Then we have other autoimmune issues such as celiac disease. Celiac disease is said to be a gluten-mediated autoimmune disease, and meaning that if you don't have gluten, you don't have the problem. Okay, so that should already send a warning flag up that this may not be an autoimmune disease, right? So when you eat gluten is a lectin, which is a plant lectin. We have lectins as well. There's animal lectins. They don't seem to cause any problems. Plant lectins do, and they cause agglutination, so they cause things to stick and clump together. So you have something like a hemagglutinin that clumps all your blood cells together, and can cause clots, can cause slowing and congestion in your blood flow, and you can get this in other areas as well. So gluten can stick to the enterocytes, so the villi and microvilli in your small intestine, which massively increases the surface area of your gut for absorption. And gluten, a lectin, will stick to this, bind to it, damage it, make it clump together, and flatten those microvilli and villi to flatten this surface out. And now you can't absorb things properly. Causes inflammation, causes swelling, causes all sorts of problems. And then your body responds in exactly the way it's supposed to, which is attacking this threat. And so you get a T cell mediated response to then attack this gluten, which is gumming up the works and damaging your body. But the gluten is stuck to your body. It's stuck to your enterocytes. So now your cells are going to be hitting the crossfire. And so as the immune systems are doing their work, they're trying to attack the gluten, your enterocytes get hit in the crossfire. It's like casualties of war. It's civilian casualties. And you get damaged. The interesting thing there, though, when you remove the gluten, even though all of those factors are still in play, you don't actually get the damage. In 4 to 6 weeks, the gut lining and your microvilli can actually recover fully. 4 to 6 weeks, there's high turnover in the gut. So in 4 to 6 weeks, you can get full recovery of the damage, even though these immune factors and antibodies are still elevated for up to 3 years. So that's the important thing. Even though there is an immune response still active, you are not getting damage to your body. So unless there's gluten there. So that is not an autoimmune disease. That is not an autoimmune reaction. That is something else. That's attacking the gluten. And so I think that it is very likely that the other autoimmune issues are something along this lines as well. So alternative theories is that this is just your body responding in exactly the way it's supposed to. You're getting attacked by some sort of environmental toxin, plant lectins, glyphosates, these other sorts of things that are strongly associated with autoimmunity. And in fact, mechanisms for causing autoimmunity with lectins have actually already been theorized and published. And so this would be consistent with how lectins attack the body and the immune system responding accordingly. There's actually a paper in 1991 that actually went through this and made this argument that not only celiac was lectin mediated, but that many other issues and diseases and autoimmune diseases in particular were lectin mediated, and they could actually bring about an immune response very similar to what we see, in fact, not similar, but exactly like what we are seeing with autoimmune diseases, as we call them. So, and again, it's very important. Your body cannot attack itself unless there was something that went wrong with that maturation process and stopped your body from maturing your immune cells properly, so that to make sure that they couldn't attack yourself, some of those would have to slip out. And if they did slip out, they would act completely differently. They would have a full court press, attacking and killing anything that it was able to be sensitized towards, and it would not stop. It would be an unrelenting assault because it has to. That's how they're designed. And you would not be able to suppress that autoimmune function unless you killed all those cells and stopped them from being able to be sensitized. But that wouldn't come back. If you got rid of those cells, that's the only way you'd be able to stop that reaction. But then it wouldn't come back later. So you wouldn't have flare and relapse, flare and remission and relapse. So that's just not the pattern that we're seeing. So something else is happening. And either way, when you stop eating certain foods, these problems go away. This is the study I was mentioning. It was published in the Journal of Nutritional Medicine in 1991 by Dr. David Fried. It is a whole article discussing and showing the evidence for the fact that lectins alone can readily explain all of the different phenomena that we're seeing. And it says here in the abstract that there's now an abundance of evidence that dietary lectins can cause diseases in man and animals. This review will deduce evidence that hitherto mysterious diseases such as inflammatory bowel disease, diabetes mellitus type 1, rheumatoid arthritis, glomerulonephritis, psoriasis, multiple sclerosis, retinitis, cataracts in the eye are all explicable in terms of lectin etiology, meaning a lectin source, as are congenital malformations, infertility, IgE-mediated allergies, and autoimmune states. So, and he goes on to say, while complete proof is still lacking in most cases, but the new hypothesis, if true, offers scope for rational therapy in these hitherto intractable diseases. And it's very important to point this out, because if you get the mechanism wrong, you're barking up the wrong tree. You're going to be searching for a solution to a problem that doesn't exist. And so you need to know what the cause is first before you try to cure something. The treatments we use now for autoimmunity is just immune suppression, because we're saying, well, the immune system's gone crazy. We need to just suppress it. And you get predisposes you for cancers, infections, and many, many other issues on top of the expense, which is severe. So that's not a very good solution. It's not a solution at all. It's just management. You're suppressing the problem. You think the immune system is out of control and it's a problem and you need to stuff it down. But that is not how the immune system works. The immune system knows what it's doing. It's not going to just attack for no reason. So there's something else going on. And I think that it's like in celiac disease, where your body's actually attacking the gluten and your tissues getting hit in the crossfire. You can get leaky gut and with lectins from gluten and elsewhere and get into your body. These can then attack multiple tissues in your body, and then this can elicit an immune response, just like we see in celiac. So we know that these get into the body. We know that these can get all over the body. We know they damage different tissues, the blood-brain barrier. They can get into the brain. Lectins have been seen tracking up the vagus nerve into the brain and getting into the substantia nigra and damaging it. When in Denmark, when they took the data for 25 years for people who had their vagus nerve cut, they found that those people that had their vagus nerve cut had a 66% reduction in Parkinson's disease. So there's all sorts of things that keep coming into play, damage to the placenta, causing permeability, allowing pathogens and other unwanted agents to cross the placental barrier into the fetus, causing other sorts of problems as well. So this is something that has actually been long studied and something we need to take a closer look at. So this is from that paper. It's quite technical, but it's basically, and people can read it if they like, but it's basically discussing how lectins can elicit what appears to be an autoimmune response. It can trigger certain aspects of the immune system in the ways that we're seeing, that we think this is actually your body getting sensitized to itself, when in fact, it could be getting sensitized to something else that's stuck to yourself and causing a very similar reaction. And that's what I think is happening. And that's a very different treatment, isn't it? In one case, you're just trying to suppress the immune system because the immune system's gone crazy. In the other system, you just eliminate this factor, lectins, glyphosate, whatever environmental toxin is coming to your body, and then the problem goes away because the immune system doesn't have anything to attack anymore. So to play devil's advocate for a minute, this is from my grad immunology textbook, and it said, the proof of this is in the fact that we can transfer this. We can see these antibodies transfer from a mother to a fetus with Graves' disease. T cells don't cross the placenta. However, antibodies can. And so these antibodies for Graves' disease go into the baby, and they can actually trigger the thyroid to turn on and get hyperthyroid and be born with signs of Graves' disease. And then taking out the serum from a patient and injecting this into mice, and they can get stimulation of the mouse thyroid as well. However, it is important to point out that this still actually would be seen with the lectin theory or the toxin theory as well, because many of these toxins can readily cross the placenta, including lectins, and or have been shown and known to cause issues and health problems with the fetus when the mother consumes these different plant toxins. And other sorts of things, such as glyphosate, et cetera, are going to be around, could potentially cross the placenta. But what they can definitely do is stay in your serum when you remove your serum and inject it into a mouse. So when you inject that into the mouse, you're injecting the serum into them. They're not isolating the antibodies. They're taking all the serum and just removing the blood cells out of it, but they're taking the liquid. And in that liquid, you're going to have lectins, you're going to have glyphosate, you're going to have all these other things that are present in the host and could elicit these reactions as well. And you're injecting that into the mouse. And again, all these things can cross the placenta. It's well established that lectins can damage the placenta and the barrier and cause increased permeability. But it has also been shown that these toxins can actually cross through the placenta into the fetus. So this is a paper demonstrating that back from 2007, looking at the toxicological properties of aloe. Everyone thinks that aloe is very good. It's so good for your skin. It's great for your gut. And this study actually begs to differ, or a review of the literature anyway. And it says here that consumption of aloe vera may also result in kidney damage in the mother and fetus, and increased intestinal peristalsis in the fetus may result in meconium release into the amniotic fluid. And it goes on to talk about the different dangers associated with this. But it shows that consuming aloe in this case, which earlier in the paper it discusses all the different lectins and toxins and things like that it contains, that these can cross to the fetus and cause damage. So if these things are able to cross into the fetus and cause direct damage, then obviously they're able to be there and be present to then elicit this immune response like Graves' disease. So what should we do if we do have an autoimmune disease? Well, the standard of care is fine for symptom management, but it comes with a whole host of its own problems. So what's a better thing to do if this is a toxin or a lectin or something else that's mediating this problem? Well, then we need a different approach. And the approach that I would lay out, and what's been working extremely well for my patients and people all around the world, is, well, just simply eliminating the offensive foods and toxins. This is best done with ruminant meat because the rumination process is very cleansing, I guess you could say, because the fermentation process destroys a lot of these toxins. And even when the ruminant animal, if you look at the different digestive tracts of like a pig versus a cow, the cow is able to break down many toxins because of that fermentation process that maybe they're not normally supposed to eat, like grains, corn, soy, all that sort of garbage and rubbish that they give them in feedlots. They give the same thing to pigs or similar things to pigs, but they don't have that ability to ferment and break this stuff down first before they absorb it. And so they're going to absorb much more of these toxins and lectins and even glyphosates that are going to then get in their body. Their liver will clear a certain amount, but some of this will get stored in their tissue. And this is likely why many people, when they go out with autoimmune issues, they do best when eating ruminant meat. So bovine, sheep, goats, venison, these sorts of things that have the complicated big stomachs, multiple chambered stomachs, seem to do better because they're eliminating out more of these toxins from not only the plants, but from the environment. You also want to reverse leaky gut. So again, no gluten. You won't want to do that anyway because it's a plant, but also casein, alcohol, glyphosate. These sorts of things can cause leaky gut and are strongly associated with autoimmunity. And leaky gut is very strongly associated with autoimmunity as well. Casein are the proteins in milk dairy. So there's A1 and A2 that refers to the different types of casein that's involved. And A1 is much more pro-inflammatory. When we first started cultivating cows for dairy, the ones we had were A2 cows. And so that's what we have sort of got used to over thousands of years. And we have more protections against this. But even A2 can be pro-inflammatory and can potentially cause leaky gut. So just be very careful with any sort of dairy products with autoimmune issues. Glyphosate, again, this is strongly associated with autoimmunity, and it is on so many things now. Basically, any sort of store-bought plant-derived food that you get will likely have glyphosate, but also the feed that's given to animals will likely have glyphosate on it as well. And pork and chicken and even fish, when farmed, cannot filter this out, ruminants actually can, it seems. There are papers coming out in the last couple of years suggesting that the rumination process, the fermentation process, actually does break down the glyphosate. And so that's not getting into the meat, that's not getting into us. And so that might be another reason why people with autoimmune issues do best on ruminant meat, red meat. In my medical practice, I'm seeing this every day. I mean, it's one of the most dramatic things that I've seen when, with the carnivore diet. People around the world, by the tens and hundreds of thousands, are coming to this and finding that just changing the way they eat and cutting out all plants is putting their autoimmune issues into remission in very short order. So that, again, doesn't make sense if this is actual autoimmune issue. If your body's actually attacking itself and thinks that your own body is an infection that it has to clear, why would it stop just because you change what you ate? That doesn't make sense. Obviously, it's mediated in some fashion. And I think that it's more in the gluten side of things where something's damaging your body and your body's attacking this. There has to be some sort of other missing third link there, because again, why would people with Down syndrome be much more susceptible to autoimmunity rather than other people? Are they just are their diets just so much worse? Are people much more remiss in how they suggest that people with Down syndrome eat? I mean, I don't think that anybody's ever looked at that, but I would find it unlikely that they're eating wildly different to anybody else and anybody in their family who's likely sharing meals with them. So there does seem to be some sort of genetic factor. And also why, when I'm exposed to gluten, I don't get a full-blown celiac reaction. There's going to be problems, but I'm not getting the full reaction. I'm not getting Crohn's. I'm not getting ulcerative colitis. And why does someone get ulcerative colitis but not rheumatoid arthritis, and so on? So there has to be some other factor going on there. But either way, when you start removing the legs from the chair, it can't stand up. And one of those major legs are these toxins, the plant lectins, possibly glyphosate and other sorts of things as well, causing a problem. You remove that, it upends the entire process. So in conclusion, the traditional way of thinking about autoimmunity doesn't make sense. It really doesn't hold water. It's not behaving as if your body is attacking itself for all the reasons that I laid out. Now, maybe it's something like I'm describing. It certainly seems to fit the phenomena, the observed phenomena, much better. I do think there's probably some other factor, this genetic factor, that we're not quite sure why some people get it and some people don't, and whether it's more people are more predisposed than others, such as people with Down syndrome. But either way, whether it's this or maybe there's full autoimmunity and partial and there's all these other sorts of things. But either way, whatever the case, whether it's the lectins like celiac and all these other sorts of things, or if it's something else or maybe your body really isn't maturing these cells properly, and for some reason they're not attacking in the normal way that we would see, either way, whatever happened, whatever the cause is, they go away when you eat like this. That's one thing we can say with a lot more certainty, because enough people have done this enough times with enough success that there's a very large signal here. And it behooves us to do larger scale prospective studies proving this, showing this, and seeing how often this works with which diseases, and get this out to as many other people. Because, with my practice and with all these people around the world, we are just seeing, miracles happen, frankly. I have type 1 diabetics who have come to me very shortly after being released from the hospital with their presentation of diabetic ketoacidosis with antibody proven type 1 diabetes. And they go ketogenic carnivore, and instantly they have much more normalized blood sugar, much more regulation over their insulin. They don't need nearly as much, and it's much more regular. They're not having these ups and downs and these swings that normally people get, especially early on when they don't know how to adjust their insulin properly. But then the really interesting thing is that in a very cause and effect sort of like way, their insulin production started to increase. And you can measure this by measuring a C-peptide. And C-peptide went from next to nothing, and insulin production from next to nothing, hence the diabetic ketoacidosis on presentation. And all of a sudden, this started to increase and increase. And 6 weeks later, one of my patients, she had now very low levels of C-peptide, below the reference range, but they were there. And so that's very encouraging. Okay, well, what about 6 weeks later? We did her tests again. Now it's normal. Now it's actually on the high side of normal, and her insulin was actually on the high side of optimal as I look at it. And she was on no insulin, and her blood sugar was perfect, and her control was perfect, and her variability was nada. And so her body now was able to recover because presumably those beta cells weren't completely dead yet. And so, like if you have Hashimoto's and your antibodies are destroying your thyroid, eventually your thyroid is going to die, and you're going to need to get it taken out and removed, or it's a cancer risk. But before that happens, if you're able to halt the disease process, then that tissue can come back unless it's fully destroyed. So some of it's going to come back, and we see this all the time with people with Hashimoto's, is that it does start to return function and get as good as it can. People with issues in the gut, such as Crohn's or ulcerative colitis, gut has a high turnover. So just like in celiac, we actually see the body heal very quickly. If the beta cells are completely dead, that's probably a bit too late, even though there are stem cells, beta stem cells still available, because those antibodies don't attack the stem cells for the beta islet cells. So if we could figure out some way of triggering those, that would be great. But if the beta cells are just down but not out, it is possible that they can make a recovery. And that is actually what we're seeing in various cases. There are actually 2 case reports published from paleomedicine actually showing this. And I've spoken with Sophia Clemens, and she said that when they stick to it, some of these people can remain making completely normal insulin for now it's 10, 15 years that she's been seeing this. And I've seen that, but the people that have stopped the carnivore diet, autoimmune issues come back, the beta cells get destroyed, and now they're fully dependent on insulin. My other patient did this. So at first he went on a carnivore diet. It controlled his diabetes, controlled his insulin, and he started making more insulin. He started improving. But then he was working away in the mine sites in Australia, and he didn't have the ability to cook for himself. And so he sort of stuck eating camp food, and just got, unfortunately, started eating carbs and other sort of normal things. But then his insulin demand started increasing. His blood sugar control started going all over the place. He started feeling pretty crappy. And after a couple of months, he said, "This is unsustainable. I can't do this anymore." And so he figured it out, and he made sure that he was back on the carnivore diet. And then his insulin control was much better. His blood sugar control was much better. And he started improving and improving. And then he noticed that he needed slightly less insulin to get where he wanted to go, and slightly less and slightly less and slightly less. And after about 3 months, a year into his disease, 1 year after his diagnosis, all of a sudden he's not using any insulin anymore to maintain perfect blood sugar control. And he actually found that his HbA1c was 4.5, which means that his average over the course of 3 months was well below the threshold that for even spikes of prediabetes, et cetera. So 4.5 is extremely low. That's extremely good blood sugar control, meaning that after 3 or 4 months, his average over that entire time was probably in the 80s, in the low 80s. So no spikes, no dips. It's just averaging out into the 80s because he checked his with the CGM, his blood sugar was very, very stable the entire time. So then he checked his C-peptide. And again, this is someone who had antibody confirmed type 1 diabetes. So it's not something else. We know that it's type 1. And his C-peptide is completely normal. His insulin is completely normal. And so his body has recovered the ability to make insulin optimally. Some people say, well, this is just a honeymoon period, but that's not actually what a honeymoon period is. A honeymoon period is when your beta cells are damaged, but not destroyed utterly. So they're still producing some insulin, but they don't come back to normal function. Your C-peptide doesn't go back up to normal. Maybe there's some variation, but it typically is damaged and then just has a slower degradation. And so this honeymoon period can sort of extend for a period of time, but it's getting damaged more and more and more, and eventually will be destroyed. This is the opposite. He's recovering the ability to make insulin and is persisting. So it's not just a ketogenic diet, it's a ketogenic carnivore diet where you're removing these lectins, you're removing glyphosate, you're removing these toxins that could be precipitating and damaging the beta islet cells. So now they just go back to normal. And just like in the other so-called autoimmune issues, even though you have circulating inflammatory factors and immune response, if there's no lectins there, if there's no toxin, there's nothing, no target there, there's nothing to attack. And so that's fine. So it's not really an autoimmune disease because the body is not attacking itself, right? And so as long as they don't go back and start eating plants or get exposed to these things, they may well be able to continue not needing insulin. Only time will tell, of course, but that's what it's looking like at the moment. And we're getting ready to publish a case series on multiple sclerosis where you're attacking the central nervous system and the myelination around the sheath. This was also described as a possible mechanism for lectins in that 1991 paper from Dr. Fried. But we have now seen dozens of patients who have actually reversed not only their symptoms and put them into remission, but have started to shrink down their lesions on their MRIs, which, as far as I know, has never been described anywhere in the literature. It's only about remission and halting the progression and then relapsing and getting worse. It slows down and then gets worse, and then slows down and then gets worse. It doesn't get better. But now we're seeing patients that are reducing their lesions by 40%, 50%, sometimes more. And we could have done this with dozens of people. We are doing about 12 to 14 just for the fact that it just takes up a lot of time and space. But this is what we're seeing now. So we're seeing so-called incurable autoimmune diseases that just stop. Not only the damage stops, but the body is allowed to start healing. So it's not just you're suppressing the immune system and you're just slowing this down. You're actually addressing the underlying root cause of the disease. And so that means that our traditional thinking of autoimmunity is wrong. Okay, there we go. Thank you very much. Appreciate your time. Hopefully you enjoyed that. Hopefully that makes sense. And hopefully other people start thinking about this and trying to show one way or the other what actually is happening with autoimmunity. But either way, the thing to do to treat it is doing exactly what we're talking about here. Cut all these things out of your diet. Just eat what people are designed to eat, and these problems tend to go away. So regardless of what's happening, we at least know how to deal with it. Thank you very much.